is equals to half Fe, which is equals to half times 20 times 1 times 10 raised to power minus 3, which is equals to 0.01 gram. Gravitational potential is equals to Fe equals to 20 times 10 raised to power minus 3, which is equals to 0.02 joules. Example 11. A spiral spring of spring balance is 25 cm long when 5 Newton hangs on it, and 30 cm long when the weight of 10 Newton hangs on it. What is the length of the spring if the weight of 30 Newton hangs on it? Assuming Hooke's law is obeyed, given length to be, we are given that the length is equals to 25, force is equals to 5 Newton, weight is equals to 10 Newtons. We are asked to find the length, what length of the spring. Solution. Looking at this diagram, when a weight of 5 Newton is hanging, the length is 25 cm. When a weight of 10 Newton is hanging, the length of the spring is 30 cm. When a weight of 3 Newton is hanging, we don't know the length. Force F is equals to Ke. 5 is equals to 25 minus L. This is our equation 1. 10 minus 5 is equals to 30 minus 25. Is equals to, due to give us in the left hand 5 is equals to 5 to the right hand. This will be our equation 2. Dividing equation 1 by 2, we have 5 over 5 equals to 25 minus L all over 5L. Therefore, 1 is equals to 25 minus L all over 5L. 5L is equals to 25 minus L. L is equals to 25 minus 5, which is 20 cm. F is equals to Ke. 3 is equals to S minus 20. S is equals to 20 plus 3, which is equals to 23 cm. Example 12. If 12 kg mass is attached to the end of a vertical wire of length 2 meter, a diameter 0.64 cm, and the extension is 0.60 mm, calculate I, the tensile stress, 2, the tensile strain, 3, the Young modulus. We have been given that the mass is equals to 2 kg, the length is equals to 2 meter, diameter is equals to 0.64 mm, extension is equals to 0.06 mm. As calculate the tensile stress, the tensile strain, and the Young modulus. Solution. Strain is equals to extension over length, which equals to 0.06 mm over 2. Stress is equals to force over area, which equals to Ke over 2 pi d squared over 4, which equals to 4 Ke over pi d squared. Stress is equals to 4 times 2 times 0.06 all over pi times 0.64 squared. 5.3 chapter. We are now in nucleus. Radioactivity. Elements which liberate high energy radiation are said to be radioactive. Thus, we define radioactivity as the spontaneous emission of radiation by radioactive elements. The steady, unvarying rate of radioactive change is best expressed in terms of half-life, and decay constant. Half-life T half of a radioactive element is the time taken for the element to disintegrate to half of its original mass, or T half is equals to 0.693 all over lambda, where lambda is the decay constant. Figure 5.2 shows the graph of half-life of number of decay constants. Decay constant lambda is instantaneous rate of decay per unit atom of a substance. Decay constant is equal to the number of atoms disintegrating per second over number of atoms in the source at that instant. Delta N over delta T is equal to minus lambda N. This is our equation 1. On integration, an exponential decay law is obtained. That is, capital N is equal to N raised to power E minus lambda T, equation 2, where NO is the initial number of disintegrating atom at a time T equals to 0 and N is the number at time T. On application of natural logarithm, we finally arrive at an expression below. Lambda is equal to 0.693 all over T half, where lambda is decay constant, T half is the half-life. The decay constant lambda can also be expressed as lambda equal to 2.303 over T times x times log N O over N, which is our equation 4. Explanation of half-life. Also, let the quantity of half-life be T in days. After T days, quantity of decay N over 2 time after 2T days, quantity of the decay is N over 2 times half, which equals to N over 4. Time after 3T decay, and quantity of decay is equals to N over 4 times half, which equals to 1 over 8. It therefore means that after 3T days, the amount decay is N over 2 plus N over 4 plus N over 8, which equals to 4N plus 2N plus N all over 8 plus 7N over 8. The amount remaining is equals to N minus 7N over 8, which equals to N over 8. Example 1. A radioactive sample initially contained N atom. Calculate the number of atoms that have disintegrated after 3 half-lives. Solution. Let N be the number of atoms disintegrating. The fraction remaining after 3 half-lives, 1 over 2 times 1 over 2 times 1 over 2 times N, is equals to N over 8. Therefore, the number of atoms that have disintegrated is equals to capital N minus N over 8, which equals to 3 over 3N over 8. Example 2. A sample of radioactive material has a half-life of 15 hours. How much of the original radioactive nuclei will remain after 45 hours? Solution. By definition of half-life, the original nuclei remain after the first half-life. Since the half-life is 15 hours, 14 hours constitutes 3 half-life. Therefore, for 45 hours later, the fraction remaining will be 1 over 2 times 1 over 2 times 1 over 2 times 1, which is equal to 1 over 8. Example 3. 4 grams of a radioactive material of half-life of 10 days is spilled on the floor. How long would it take to disintegrate 3.5 grams of the material? Solution. Half of 4 will disintegrate to give us 2. Half of 2 is 1, will disintegrate to give us 1 gram. Half of 1 will disintegrate to give us 0.5. So we add the disintegrate, therefore the time it will take is 3.5 grams to disintegrate.